Optimizing the Engineering Team Structure with James Avery.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back to the show. I'm Jeffrey Palermo, your host. Make sure to check out www.azuredevops.show for the past episodes and show notes. And once again, the goal of this podcast is to empower you and your teams with the information that you need to move fast and deliver consistent quality using the .NET ecosystem and run your software systems with confidence in Azure. And for those of you running .NET and Azure user groups, I've been doing a lot of online video presentations. And if you run one of those groups, I'd love to give a presentation for you. Our sponsor and my employer, ClearMeasure, is a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. And so if we can help, please get in touch. And if you are a .NET developer and would like a path to become an architect, we're hiring. Just apply on the website, clearmeasure.com. And also, I've just launched another podcast, but a video podcast this time. It's called Architect Tips. And most of the episodes are very short and aimed at showing you something very useful for designing software that's built on the Microsoft platform. And we focus on the Microsoft platform here on this podcast. But when it comes to success stories, we pull them in from everywhere because architectural elements and problem solving and ways to look at software and cloud and everything come from all walks of life. And so we have a very interesting success story to share today. And this is one of those exciting shows. Well, I'm very excited for today's guest, and it is none other than James Avery. And he was a guest on show number 51. And after a year and a half, he's back. James Avery is the founder and CEO of Kevel and longtime friend and software architect extraordinaire turned business leader. James, how are you today?
I'm doing great. Thanks for having me back, Jeffrey. I didn't realize it had been
my pleasure.
Yeah, I didn't realize it had been so long.
Hey, time flies when you're having fun.
That's true.
But last time we talked, and for those listeners who didn't start listening to the Azure DevOps podcast until more recently, go back to show number 51. We talked about the journey of scaling to 3 billion requests per day. But for those who aren't familiar with that podcast or your company, why don't you start us out with the quick story of the company and kind of what you do and why you're doing some interesting architecture stuff and the whole business.
Yeah, absolutely. So Kevel is essentially APIs for online advertising. So we work with companies to help them build their own ad platforms. So you look at somebody like Twitter or Facebook, and they've built these really sophisticated ad platforms. We believe that everybody else, all these other companies should be able to build that level of ad platform without having to build everything from scratch. So, the way we kind of look at the world is that advertising can be better. It shouldn't all be owned by Google and Facebook. And there's lots of opportunity, but it's a really big investment. The challenges we have to solve when it comes to scaling and making these decisions and 10, 15 milliseconds and reporting, it's a lot of stuff. And so by providing a set of APIs, companies can build on top of those APIs. So in short, if we were in an elevator, it'd be, hey, we're Twilio, but for advertising instead of sending text messages.
So who would be the target customer? Is it anybody that has a decent traffic website?
Yeah, it's usually companies who, it could be e-commerce companies, people like Edmunds, where you're going to research a car and they want to show a really high quality native ad. People like Strava, even where Strava is using us for, when they want to tell you about, an upcoming event or they want you to upgrade to Pro. So there's kind of all these different uses. And we have pretty wide use. I mean, even digital billboards, a lot of times. So we have a number of those customers that run those using our APIs. And that's really the fun of running an API business is that we're always surprised by, people that come to us sometimes. There's customers that we know are a good fit, and we actively pursue things like food delivery. But then, somebody comes to us and says, we want to run ads on this billboard, or we want to run them in this jukebox, or, in a car. And we're like, sure, you can do whatever you want. Like, here's the REST endpoint, right?
Nice. So do you guys source the ads themselves? Do they just tap into your network, or what does the customer have to do on their own?
Yeah, no. So we don't sell the ads or source them. What happens is our customers are selling them, or they're building self-serve interfaces, which is a lot of times what they're doing, right? Like they want their buyers to just come to them, create a campaign, run that ad, and put in their credit card. Okay. And so the customers will go and build that kind of on top of our API.
Yeah. Okay. So very different from Google ads, where you say, hey, I don't care who puts an ad on my website, just here's a spot where stuff can go. Whereas really for you, they know who their customers are, but it's like, okay, how do we charge them the right amount?
Yep. Yeah. And the Google approach is like, when, back in the day with our blogs and things like that, right? It's like, yeah, a lot of times you would just do that. But then, if you have a really good audience, if you have, a really certain aesthetic, and you don't want to, have a kind of crappy banner ad, on your site, like you're going to want to sell it direct. You're going to want to be really careful about advertisers you take on and things like that.
Yeah, you mentioned blogs. There's probably a lot of people who don't even remember the tech blog era, but Twitter or microblogging kind of killed the long form blogging where we all had our own website. Do you think that's going to come back now that microblogging is like not?
I don't know. I do miss it though. I mean, that's kind of how I guess we met through the conference circuit. But way back in the blog era, like, and how this all started was I ran a small ad network for kind of .NET developers, the Lounge, which you were a part of, and guys like Rob Connery and Phil Hack and Scott Hanselman, and yeah, everybody was writing blog posts and linking to each other, and was it not postbacks? Was it pingbacks? Pingbacks. Something like right, like trackbacks, like back before they were filled with spam. It was a really interesting time, but yeah, it does feel like Twitter and now even too things like Medium or Substack. People are like, I'm going to build a newsletter instead of writing a blog. Right. It's definitely, it's like it makes us sound old. Now we're reminiscing about the middle 2000s.
Right. Well, it gives a good perspective, just big aside. Whereas with all the uproar with censorship going on, it makes us realize or even question, what is the architectural differences? And I reflect and think, well, okay, an email address, there's a whole protocol around email where you say, you know what, even if it's provided by Yahoo, the agreement is that I own my email. And blog, I own my blog. And architecturally, I'm running the DNS. But when you use a social media platform, regardless of which one it is, it almost doesn't matter which one it is, you're using a service and you don't actually own anything. There's no protocol. Right. And it's just fundamentally different.
Yeah, it is fascinating, because I think when with all the talks about censorship and things like that, nobody was turning off people's DNS providers. Right. Like nothing was stopping anybody who gets kicked off Twitter could set up a, text file and serve it from a server, right? Like, when you get into like AWS cutting somebody off, like, oh, that would be rough, right? Like if, most people are on a given cloud, if it got cut off, you'd have a hard time. But at the end of the day, like no individual is being muzzled, because there's plenty of ways on the internet to put up whatever you want and keep it hosted. Right. With no censorship.
If that wasn't true, then WikiLeaks would have been taken offline, or some of these other sites that are
all these things like Pirate Bay and stuff like that have just been running for decades. And so and we could go off on a tangent on this, but I think that a lot of people are looking at how does crypto build a new decentralization of more things, right? Like even when you look at something like DNS, right? Like there's protocols out there people are building to say, how do we decentralize DNS? So it's not really just these handful of big companies running the big, backbone servers or ICANN or whoever it is, right? Like it'll be really interesting. I think the potential, people always talk about things like consolidate and then they explode. So it feels like we've been in this like consolidation mode,
right?
Of, it's Twitter and Facebook and a handful of things. Like, are we going to get back to like an explosion mode? Like what's the thing in the next like 10 years? Like we're all going to go create and be like, oh, I created this and I'm running it on a little drop at DigitalOcean. And it's like, that's all I have to do. And it sinks into everything else, but now we're in like sci-fi territory.
Yeah. Well, 2 episodes ago, I guess was Charles Flatt, and he provided a analogy for architecture that I'd never heard, but I'm thinking, why wasn't I taught this when I was 18 years old? And he said that developing software systems is not like designing a building or designing a house. It's like designing a city. The roads and all the different infrastructure are the key things that you're making. You don't know what house is going to go in a certain area. And when we were talking about protocols and DNS, that brought that back because when we have just a software system, a single software system even, and we can use it, great. But whose ever that software system is calls the shots. But when we have a protocol that people in the industry, well, now we're living in a software city where, okay, I can be over here in this part of the city and you can be over there in that part of the city. And nobody says, hey, you must leave that city.
Yeah. Well, it kind of brings back to like we all like to call things like dumb pipes. Like there's a reason for that, right? Like there's a plumbing system in New York that was built hundreds of years ago that a brand new skyscraper hooks up to the same fundamental plumbing architecture that the house from the 1600s is hooked up to, or 1700s is hooked up to. And so it really is like, it's an interesting way to think about architecture. And also the other thing I think is funny to point out there is, they're doing these new subways in New York, right? And everybody's pissed because it's costing them like $1 billion to go like a mile or something like that, or some $1 billion. But as architects or developers, we understand why, because you're trying to build a new pipe in a 200-year-old software system versus if you look in places in China where it's a subway and a new city being built from scratch, that's some good greenfield subway development, right? You just slap that thing in there and you're happy.
Yeah. Yeah. And people in New York, they kind of frown on buildings and sinkholes collapsing.
Right. Yeah. Well, and like just like we frown on like taking down systems that we didn't intend to with our refactoring or re-architecture.
Right. Well, that was a fun little aside.
We can go down this analogy for hours.
Oh, totally. Totally. Now you've done some really interesting things with Kevel, but for people not familiar, can you give a quick overview of the technology stack that's under the covers?
Yeah, absolutely. So we built, there's a lot of different tech involved, but the kind of base of it all is AWS. Like we're pretty heavy AWS users. We run out of, I think 5 regions right now. And that's because we have customers all over the world. Latency is really important. We're pretty heavy users of both Clojure and Node. And so a lot of our systems, a lot of the delivery systems are built in Node. A lot of the kind of management and backend services are all built in Clojure. But yeah, like you mentioned, we're doing billions and billions a day of requests, and each one of those requests has to happen pretty quickly, like anywhere from 30 to 100 milliseconds. And in that time, we have to evaluate potentially thousands of potential campaigns or ads that could be targeted, have to include different levels of targeting, geo-targeting and keywords and all this really kind of complex stuff, like in a really, really quick way, with like 0% downtime. Because for us, if it's down, then it's costing people, actual money.
Right. All right. So you're all in AWS, how do you reason around regions or disaster recovery or those topics?
Yeah, I mean, I think that the two things there is that one, different systems have different levels of like where, I guess, availability, right? So like different, like with delivery, when we think about people making calls for ads, which is really tied to their revenue, that's the system that's in the most regions, and that has the easiest kind of failover between regions, and really has kind of a share nothing architecture. Like one of our things has always been every engine, which is what we call one of these servers, is an island. And so, it's like that. I might have told this story last time, but like the myth about the server that gets like drywalled in and just keeps running for like decades.
Yep.
Like that's the goal, is that they should really just be able to run without external requirements. And then, of course, you're still subject to AWS. If AWS region decides to go down, then we use DNS and things like latency-based routing to be able to route around any regions that are down.
And how often does that happen, where you have a hiccup, and if you hadn't designed for something, you would have had a disruption in service?
It's funny. Like we've been using AWS. I was looking back at it. Like I think I signed up for AWS in 2008 or 9.
Mm-hmm.
Yeah, it was somewhere around there, like maybe 2009. And back then, it was a lot less reliable. You're more likely to have issues. You're more likely to have all of US East go down and things like that. Lately, it's pretty reliable. I mean, I think we've had a couple. I remember there was a decent sized kind of EFS outage a year or so ago, but it was only one region. So for the most part, it's not happening very often anymore with Amazon.
Yeah.
A big part of that, right, is that we've built internally. It's pretty optimized to where we have a lot of engines behind load balancers. They don't rely on single backend services. Like it's all been built so we should never cause it to have an issue. If it's an issue, it's usually coming from something like Amazon, which has really been pretty infrequent, especially in the non-US East regions. Like I think US East is there in New York from the standpoint of how hard it is to make changes there and update it. So it seems to be where most issues happen out of US East versus like Singapore or Frankfurt or any of those places.
Gotcha. And how many running processes make this whole system work?
Oh, that's a good question. I mean, it's thousands. I don't know. Well, I mean, if we're actually talking about like CPU processes, right? Like, or if you're talking about like services.
Yeah, unique applications, unique services. I mean, yeah, you may have 100 of a certain type running to balance the load, but how many unique little applications are running around?
Yeah, it really depends on, if we look at delivery is pretty optimized to be, it's a single process that you're calling and getting back your answer. And that's just by nature of us trying to get latency as low as possible, and not, we don't want to, like a micro architecture kind of microservices thing can be great, but it also just adds lots of hops in between, and every hop has some amount of millisecond latency or sub-millisecond latency that adds up. So when you make a request to us to get a response back, it's all pretty self-contained in one process that's trying to get that response done as quickly as possible.
Okay. And how many engineers roughly?
Yeah, how many we talked about a little bit before the show, but we recently raised an A round and started scaling up a lot. So we're at about, I want to say it's 15 to 20 engineers at this point. We have a couple open job recs too. So if anybody out there is looking.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
And you have a unique take on how to structure a software engineering organization and how to figure out, okay, how many teams do I need and how to align them? What's your philosophy there?
Yeah, so we actually just made a change recently that I think is a little bit different than how a lot of people do it, and it's fundamentally hard, right? Like when you have a team of 5 or 6 engineers, it's pretty easy to coordinate with everybody to get things done. You probably have one PM or a project manager, but as we started to grow, we found that gets harder and harder if you keep the teams aligned with kind of their horizontal slice of the organization, right? So, and previously we'd have a team who was focused on just delivery, which is the serving of ads or requests, and then we'd have a team that was focused on the kind of management API and UI. We have a team who's focused on reporting and kind of the back end data, and we found that to get one small thing done, right? Like you want to get a field added to the UI that goes back into the ad system that then gets reported on. You now basically are including, every PM across the whole org. It's like all 3 PMs have to work together. All the lead engineers and possibly other engineers from the teams have to work together to do something that, if you were just starting a new system would take you a couple days, right? Like fairly simple change. And so the way we decided to approach it was to rethink it and say, what if we aligned product and engineering teams based on business objectives? So I'm a big fan of this book called Inspired by Marty Kagan, where he talks about really empowering product managers and really giving them business goals versus giving them tasks, right? Like product management is probably the, where, 2 product management jobs could be very, very different from each other, depending on which company you're talking to. Mm-hmm. And what we wanted to work towards was we didn't want product managers to be kind of being given tasks from on high, right? Where I'm saying, okay, these are the 2 things I want to get done this quarter, or these are the 5 things I want to get done this month. That instead, product managers got to be really the kind of mini CEO role over a certain piece of the system. But that's really hard, right? If you say, well, you're the product CEO of the UI, and you're the product CEO of reporting, and you're the product CEO of delivery, well, they're not really CEOs now, right? Because they all have to work with each other to get anything done. So what we did was we realigned it around a handful of business objectives, which one is, keeping our customers, delighting our customers. So it's kind of called the customer delight group, right? And so that PM can work hand in hand with customer success, with our account managers, talk to our current customers. How do we make sure our current customers are being as successful as they can on the platform? So, it could be bug fixes, it could be improvements to the platform, it could be, those things that maybe would never get prioritized otherwise, but are really important to customers. And now that PM has one focus, which is current customers, be delighted, stick around, keep paying us, right? Mm-hmm. And then we can have another PM and we can focus them on developers. And we can say, okay, so we really want, we're an API platform. We really want developers to have an amazing experience using our tool. And so he is fully focused on talking to developers that are on our platform. It could be developers that are prospects that are thinking about using us. It could be developers that are currently using it. They've been building things like SDKs and troubleshooting tools, and and then they'll hear, oh, the API has this field you have to set that's really annoying because it's required, but then it's not always needed. And so then they can go in and they can then go make that change to the API. It's not a matter of like putting in a ticket and trying to get it prioritized somewhere else. Like they're empowered to make those changes. And then we have another team that's focused on new revenue, right? So that product manager, we say, you're going to work with sales, you're going to work with solution architecture, and you're going to figure out, what are the things we need to be building to close more deals, right? And it could be an immediate need. Like, we could sign this huge customer, but we're missing this security checkbox feature, or it could be, oh, if we built X, I think it would give us access to this whole new market. But the challenge with that is that it makes a ton of sense from a product management standpoint, but it's a lot harder from an engineering standpoint because now you have a team of engineers where they either have to be totally full stack, right, and can do everything, or that team has to kind of organize and work together to figure out how to get work done. But if you keep the team small, the belief is that, if you I've always felt like when I was an engineer, if you're on a team of like 3 or 4 engineers, like you would just figure it out. Right? Like it wasn't like, oh, you're only UI and you're only on this thing. It'd be like, well, look, guys, like we have this stuff to do this week, and I can get this UI stuff done in like 3 days. Let me go do that. And the other guy's like, well, like I don't really know this system really well. And the third person's like, well, hey, I'll pair with you and we'll knock it out this week. Right? Like and letting them adapt and figure out what works and really like work together as a small cohesive team. Like every time I was on a team, it's like once you were at 3 to 4 people was like optimal speed. And then they'd say, oh, we want to go faster. So they'd add 4 more people to your team. And then suddenly you're like 8 people and you have a project manager doling out cards. And it's like all this organization overhead.
Yeah. Yeah. The spirit of the self-organizing team.
Yeah.
But at some point it's hard or less practical to self-organize.
Yeah, and I think we found a way to try to make it work. We just made this change a couple months ago, so maybe another year I'll come back and give you an update on how it's going. But so far it's been encouraging. But then and the other piece that I didn't mention was the challenge with that kind of team structure though is who builds that new subway under New York. Right? Like who does that? So we have a separate team that doesn't have a PM that reports up to our CTO or our VP of engineering. And they're focused on the core platform and making sure that, hey, this is going to continue to scale and that it's going to have the uptime and the reliability we need. And so they can be both mentors to the rest of the team because they're, more senior experienced engineers, but they can also work on those things that a PM never wants to prioritize. Right? Like, oh, we want to switch out, technology X for technology Y because it'll do this. That's not always tied directly to more revenue or customer delight. It's kind of tied to overall health of the platform.
Right. And these success stories are really interesting because there's no textbook that can cover all different scenarios, and especially in a high scale environment or an environment where you can't go down. It would be very bad for your customers if you had downtime or outage and the API started throwing errors. But what's been the approach to test at the various levels when okay, we need to make sure that this API goes to this scale, or if something happens, we don't get the disruption. How do you craft those automated test cases so that they can actually have any chance of proving that?
Yeah, it's definitely a challenge, and over the years we've taken a couple different approaches to it. First is like there's the test for like correctness, right? And what we do there is actually kind of be able to replay traffic is the key part, right? It's been able to say like, well, I'm going to simulate all the traffic from yesterday or from 2 weeks ago on this new system and kind of pre-prod, and make sure that the correctness is still there, that what we were expecting to happen will happen. And so that's the kind of the number one, that is, replaying that traffic. That helps some with scalability, but the thing is that things are always changing, right? Like you can assume that from a correctness standpoint, what happened last week is a pretty good proxy of what will happen the next week. But when it comes to a live traffic, everything is changing, right? Like maybe there's a game on that causes the site to go crazy, or there's different types of ads that have been loaded. And so one of the things we've always also done is, we don't, I think in a lot of systems, especially like enterprise systems, right, you can kind of do the Indiana Jones approach to deployment, right? Of just like, swap it real quick, right? Just swap the statue on there real quick, and like everything's gonna be fine. Because we run so many of these engines, we've always taken this kind of delayed or kind of staged rollout. And so, we do things like canaries is what we'll call them, right? Where you say, we're going to move one of the, 20 engines in this cluster to the new system. And then we'll evaluate how it's performing versus the old ones. And so to do that, you have to make sure like APIs are all compatible. Everything's always backwards compatible. There's no, there can be no, switching of the statue in the temple. We have to make sure those things are all backwards compatible, but that way we can really put something out there. We can measure it. We can look at revenue. We can look at everything and make sure that it's, behavior we expect. that it's not dramatically slower, right? Like that's what happens a lot when you're in, if somebody makes a change and they didn't think about what could happen, you want to be able to catch that really quickly. And so by doing it that way, replacing one engine in a large cluster out of, multiple clusters, you can really kind of just trial by fire and see what happens.
Okay. Well, that brings a question about the deployment pipeline structure. So you've got multiple services to deploy, but each of those is deployed to many instances. So all the books and the texts for putting together a DevOps deployment pipeline show, okay, you're gonna do something with your data storage, you're gonna do something with the process, but you've got on top of that hundreds of running instances of that one particular service that just got modified. Are there any things that that y'all figured out that just wasn't totally obvious when you put it in place?
Yeah, I mean, I think it's pretty common practice now in kind of these high scalability environments, which is that we never update anything in place, right? Like, you have a ASG, you have a group of engines. If you want to replace it, you actually are rebuilding the AMI that has that software, and you're launching new versions, right? So there's no because upgrading in place is always just has room for error compared to bringing up a new server with the latest code on it
and letting the other one die.
Do that, letting the other one die off, right? Like that's the approach we've taken, and we've done a mix of. I know some systems we've been trying to move to CloudFormation for most things, but we also have some custom stuff that we wrote before. We kind of wrote our own mini chef-like kind of thing that we used for a while, but now CloudFormation's kind of caught up and is doing better.
Okay. All right. Awesome. Now you have such a massive amount of data. You do tons and tons of indexing. How much is just in memory versus how much is storage providers are you using?
Yeah. So there's a couple things here, because there's the data that comes in about how ads are performing, right? Like, did we show it? Did somebody click on it? Things like that. That's all pretty standard in that we get all that data in, we ship it off to Redshift, we run it through Hadoop kind of things and stuff like that to get it in the structure that we want, like a data warehouse. The bigger challenge is always how many campaigns are you going to evaluate on a given request? And so this is where, it can't be, actually, if we go way back, right, when I first started this, writing code for the lounge, it's like, well, I ran a select against a table in SQL Server, right? Like that seemed very reasonable for the, 10,000 requests a month we were doing. Obviously, that's not going to scale unless you want to spend, $1 billion on SQL Server. So then it graduated where you start to think, okay, like it all has to be in memory. And so it all has to be in memory in some way or another. And so, we use, historically, we've used things like Redis, also like caches in each process, right? Like the things that are being used frequently, we want to cache in process so you don't even have the slowness of hitting Redis. But recently, some of the work we've been doing is building our own kind of custom in-memory indexing so that we can do this even faster. And so that's when you really get to the scale of saying, I want to evaluate millions of ads to see what the right fit is. That's when you really it kind of breaks any current off-the-shelf technology, and you have to figure out how to build in-memory indexes to really make this as fast as it could be.
Correct me if I'm wrong, but it seems like math can guide you here. If there was a data storage component that had, even if you could do 3 million requests a day storage, and it had a return time of some small amount, but the latency added of just hopping on the network and then off to anything would immediately, sounds like, disqualify that as an option. And that's why he said, no, we got to get it in memory.
Yeah, well, we could run it, like you can run things, like with Redis, we often run Redis on the exact engine, right? Because it goes back to the every engine is an island kind of thing, right?
On the server, on the operating system. Yeah. So you're still hopping out of process, but you stay on the same box.
Still hopping out of process, but then the cost really is right. Like is a lot of times it's the serialization is what gets you more so than than network latency.
Okay.
Right? Because you can make a call. Network latency is fine, but let's say, indexes are great, but indexes don't get you all the way there when you have a lot of custom logic. Maybe you're saying, well, I only want to target people in this certain area at this time zone. Like those things you can query for. But then you might say, oh, I actually have some custom logic written that says, well, I only want to target people if they recently searched for a Toyota Corolla and things like this. Like you can't index everything, right? Like otherwise it's not indexed. You're back to doing a table scan, right? And so if you have to pull back, n number of these potential candidates or ads, that serialization cost and cross network cost actually becomes more so than like the actual search latency.
Awesome.
So the more we can do in memory, the better we're always off.
All right. Well, we've gone a little bit long, but this is awesome. Great to update with you, James, and just good success stories. I love having DevOps and cloud success stories on here. Yeah, we're the Azure DevOps Podcast, but when it comes to a success story, it's all about architecture and just learning all these different scenarios, because so many of the decision points and the architectural elements are transferable across just a large number of technology options. But anything you want to close on, James?
No, I mean, I think maybe when I come back in a year, we've talked about exploring multi-cloud and how to run in Azure as well. So maybe we'll have an update on that in a year. We'll see.
The harbinger. Awesome. Well, thanks so much for coming on the show and spending some time with me.
Yeah, thank you.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.